and explain to you by example how we might read some data into R and do a particular analysis on it. So let's take as our example a data set that's quite well known. It's built into R, but I'm going to suppose that it's data that we've taken ourselves, and it's called iris. So let's suppose we have data on 3 species of iris, and for each of the observations we have recorded the sepal length and sepal width, and the petal length and petal width. And let's suppose we have 50 observations on each of the 3 species, so 150 observations in all. Okay, so where is our data? First of all, we've got a project. Here is our project, the top level of it, and in that project we've got our data folder, and there is our iris data, okay, which in this case is saved as a CSV file, which you might well want to do. Later I'll show you how it's when that's not convenient, when your data is in the form of a spreadsheet, for example, an Excel spreadsheet or a Google Sheets sheet or whatever they're called, you don't have to convert them always to a CSV file. But let's suppose that's what we've got. Okay, so we've got our data in the form of a CSV file there in our data folder, and what we want to do is create in our scripts folder a script that is going to do the analysis that we want. So let's create that script first of all. So we go to File, New File, our notebook. So we're going to do a Markdown script, and then we get the usual exemplar stuff, the exemplar YAML and the exemplar example of stuff you could do. But we're going to do what you normally do, which is delete all that. Boom. Because that's where this blank space is now our canvas, where we're going to put the stuff that we want to write. Okay. But what we're going to do first is we're going to just save this as under the right file name. So I'm going to save it in the scripts folder of my project. So I'm going to call this one iris2 actually, because I've already got an iris1. But so there you are. Some name that makes sense to you. Okay, save. Okay, and when I do that, if we go and look in the scripts folder, you'll see there it is, iris2.rmd for R Markdown. Okay. Because we're writing a Markdown script, our script files are saved as .rmd. Right, but essentially they're just text files. You could actually edit them in any text editor, including Word, though I wouldn't recommend that. So now to work. Okay, so here's our YAML. So we'll change the title to Iris ANOVA. That'll give you a clue as to the kind of analysis I want to do. And then we will give it a date, which today is the 12th of the 6th, 2022, and then author, and that's me. And as I've said before, we can add lots of other lines here, but for the moment and for your entire R career, if you want, you can just leave it at this, okay? But just don't delete the stuff between these 3 dashes here, okay? So then we move on to the actual script. So typically we would write here some stuff to remind us or our collaborators later on what on earth we're doing. So we are going to analyze the iris data set to determine whether there is evidence of a for weather. So let's get rid of that. If there is evidence for whether the sepal length differs from between each of the 3 species. Now I could go on and write more stuff here, but you get the point. We're just trying to write something that is informative to us, okay, informative to our collaborators, and we could write all sorts of things, and we could even get rid of the typos. That would be good. So the first thing, so that's some text, okay, which here hasn't got any fancy formatting at all, because I don't need it. So the next thing I'm going to do, I'm going to start to add some R code chunks. Right now, normally I would add one code chunk that would affect the way that all of the chunks look once I start to format them. But for today, I'm not going to bother with that one. I'm just going to put a little header in. Remember, hashes mean headers. Using that help window, help, markdown quick reference, hashes mean headers, okay? So smallish header, 3 hashes, okay? So I'm going to load packages, okay? So most scripts require the use of some sorts of packages. And this one will be no exception. So I'm going to include an R code chunk which does the loading of those packages. And this is how I do it. Now I used on my Mac Option Command I. You could use Option Control I on a Windows machine, or you could just type this in manually. It doesn't really matter how you do it, but if you want to put R in, you have to put 3 backticks, curly bracket, little r, curly bracket, then that's where your code goes, and then close it with 3 more backticks. So we will have here library tidyverse. This is an unbelievably useful package that I recommend that you load into every single script that you write. Okay, this one, and the next one, is nowhere near as extensive. We will in fact use one function from it, also called here, but it is incredibly useful too. We use it to read data into R. Okay, next one, library calplot. You probably have never heard of it. I use that because it helps me make my plots look nice. Okay, next one, ggfortify. This is one of several packages that is built onto the capabilities of ggplot, which is a sub-package within tidyverse. Basically, it enables us, we use this one for when we want to do diagnostics of our data to see whether the types of analysis we're attempting are valid for the kind of data we've got. Okay, so that's what that one's for. Sometimes I add other packages, but I pretty much always add these, and I recommend that you do. All right. If you have a kind of standard way of working where you know, right, the first thing I'm going to do is load some packages. Those packages will include these. You just get on with it and do it, and it makes the writing of your scripts that much quicker. The initial stuff is just done quickly. Right, so we've loaded our packages. Boom, next one. We will read in our data. Load data. All right, so this is how I go about loading in data. First of all, I create an object called filepath. And I try and spell it properly. I use that assignment arrow, and I now use the here package. Okay, here, and I say something like this. I say data, and then I write the name of the file that I want, which is iris.csv. Okay, and I'm just going to run that packet, run that script, run that chunk rather for you. Okay, but before I do that, I have to run this chunk. Remember that you can run each chunk individually, but until you run this chunk, subsequent chunks don't know about whatever this chunk does. So what this chunk does is load into R the capabilities of these particular packages. I'm just going to run it now. Okay, and you see it happening down here. Okay, now that I've run it, the R session that I'm working in knows about the functions that come with those particular packages. So the here package, what it brings to us is one function here, okay? And if I run this chunk here, right, file path, what that does is create an object called file path. So can you see up here in my environment window, there's an object, it's called file path. And that file path is, and let me just sort of write it out down here in the console window, file path is nothing other than the whole pathway from the top level of my machine right down to the particular file that we want. Now that is a humongous and awful, if you like, file path to have to remember. And it's not something you want ever to remember, and you probably couldn't. In particular, you don't want to ever code something like that directly into your script, because the moment you do, you have made it such that your code is now very fragile. The moment you change the way your files are arranged on your machine, this won't work anymore. Okay, this file path will no longer be valid. The moment you send your file to someone else, this code won't work anymore because that file path won't be valid on their machine. here gets around the whole rigmarole of where on earth is my data file on my machine, as far as R is concerned. The way it works is it says, right, here is, and let me just write here is this. This is the pathway to the top level of your project file, right, which is here. Basically, that's here, as far as here is concerned, right? It means the top level of your project folder. And all that stuff is just taken care of by the here package. You don't have to know about that anymore. Then what you've done then by here writing this line here, file path, is this object that we've created, is the here function acting on these arguments where data is the data folder. So it says basically go from the top level of my project into the data folder, and then there is my file. Now we could have had a whole sequence of subfolders if we had them, but we haven't, right? So this is how I go about finding my data. I make sure that my project folder always has the same structure. It always has a scripts folder, and it always has a data folder. And that means I can, if I use the here package and this here function from that package, then just by writing this line, so go to the data folder, then go in there and find whatever the file name is, it will always work. Okay, it just makes that whole business of getting your data into R so much simpler. It's the same thing every damn time. Okay, so the next thing we're going to do then is we're going to create an object within R, which is our data. So let's call it iris. Okay, so iris will be, and now we're going to use a function from the tidyverse package. Remember, it's that unbelievably useful package, which is actually just a collection of several other packages which we're going to use time and time and time again. So iris will be read CSV and then file path, which basically tells this function where to go to find iris. Okay. So let me just run that line. Can you see I can put my cursor anywhere on that line and run it. Boom, file path. Then I can place my cursor on the next line. Well, it already is there, and run that. Can you see, look, that implemented that line, and now up here is that object called iris. And by clicking on this little circle with a white arrow in it, I can get to see what that is. And I recommend that you do that. Okay, this is one of the many, and this is one of the simplest ways where you can start to figure out whether the data that you've read into R is what you were expecting. Because it may not be, right? So this one says that we've got a column called sepal.length, one called sepal.width, one called petal.length, one called petal.width, and one called species. And the first four columns are numerical data, and there's 150 rows of them. And the last one is CHR, which means character, which is R-speak for text. Okay, 150 rows of that. So that actually is what I'm expecting. So I hope it's what you were expecting. But that's my general point is you typically have a look at your data. By clicking on the name of the data file up here, boom, you get a kind of spreadsheety look at it here. And often that's really useful. Does this stuff look like you were expecting? Are there extra phantom columns that you weren't expecting? Are there extra phantom rows that you weren't expecting? Sometimes there are. When you play with Excel, you often get weird stuff going on. So this is a quick way to find out whether that weird stuff is or is not going on. But we can also use there's a command in R called glimpse, and I'm going to now glimpse the object that I've created, glimpse iris. And I basically get the same information that we just looked at. What columns I've got, how many rows there are, how many columns, what kind of thing is in those rows. Double is R-speak for numerical data, numbers. CHR, again, means character, it means text. Okay, so that is my standard go-to code chunk for reading in data. I create a file path using the here package, which works because I have made my R folder into a project. I didn't emphasize that. Here only works if your R folder is itself a project. Okay, so we went through the rigmarole. Well, it's not a rigmarole. It was very easy actually of making it into a project. That creates the path that we need. Then we use that to read the data into an object called something sensible, and then we have a look at it. And there you are. That is how you get data into R.